Okay, so it looks like the total structural length of our bridge here is 22 inches, and then we can choose how deep it goes into those little corners up to 1/2 inch or 1 inch. Some of the things that we need, some of the requirements are each model bridge should support a minimum of 100 pounds and have a weight ratio of at least 250 to be judged successfully. All the force will be judged from this middle point right here. If we're taking the force from this point here, having these beams go out diagonally like this might be better.
As opposed to a Howe bridge,
yeah, because
which is not supported in the middle. I was sitting.
As you can see, as we increase the number of web bays, we calculate the forces. See the max force is 91.7. And if we increase it to say 3, it's still 91.7.
Okay.
So the weakest point will still break at the same weight, but if we increase the height, then it goes down.
Then it goes down. Okay.
So,
All right.
So here it talks about gusset plates, and I've actually had a little bit of experience with these before when you were doing modeling bridges, and we used just small pieces of cardboard, and it did make a decent difference even with something as weak as the tiny pieces of cardboard. So we'll definitely consider this and factor that in our bridge design.
Okay, good idea. Okay, Jackson, what were you looking at?
We are looking at GarrettsBridges.com. He's giving us some information about the types of truss bridges, and we're specifically looking at his response to Lil Roy, where he says that he personally prefers Pratt trusses, which is what we previously were talking about. So it looks like Garrett is confirming our hypothesis.
Good stuff. Okay, so here are some of our initial notes from the first day. So we're thinking about doing a Pratt bridge design just because it has these lines are coming out from the center, because this is where the force will be right there at that point. It's going to be 22 inches long. We haven't figured out a height yet, but just for initial stuff, we're saying 6. This is the side view. This is the top view right here. Basic ideas, and then here's some questions. What are the number of web bays we should use? And then what is going to be our height? Has to be greater than 4. And then here's some of our math here. End up choosing a number of web bays, what our angle is going to be, and what the distance of each section is going to be. So
we decided on a height of 6.5 inches for our truss, partially because we ran simulations and we figured out that it's a good balance between balancing the amount of force on each part of the truss, and also because it's small enough that it should still help limit the swaying and flexing motion side to side of the bridge under load.
yeah, and then if you do the math as well, it ends up being basically around each angle right here is basically 60, is approximately equal to 60. So it just makes it easier during the craftsmanship process of building a solid bridge, not having to do an exact 72-degree angle. Because of all these reasons, we decided to go with the Pratt bridge. After this, we started planning for the building process. Colton's working on this little prototype brace here.
for our prototype, we built just the middle truss of one of the sides. What we found was that cutting the sticks to one cut instead of 2 cuts was much easier for assembly, and that the gusset plates made it much stronger.
And then I'm working on the inventory. So this is going to have a list of every single thing we need. So this is our list of things that we need for the sides, the ceiling, and the bottom. This is the total of everything. Obviously, that all combined together. And then this is what each individual person is going to come in and cut out on their own free time.
Because we were satisfied with our initial prototype truss, we began building our final design. We started building from the top of the bridge, making the bottom rails I-beams, and then connecting them together according to our design. After this was done, we realized we would need more support because there was still a lot of space that was not reinforced. Because of this, we decided to add more diagonally spanning pieces on top of the I-beams, and then rest the roadway on those supports instead. These diagonals were offset from the original ones to ensure every part of the bridge was supported. After gluing the trusses onto the top of the I-beams, we were able to connect the top of the trusses together with X-shaped supports. After the full frame of the bridge was done, we cut and glued gusset plates onto the outside of every joint in order to add extra strength. We then thought of adding additional gusset plates to the inside of all the joints for extra support, which we implemented into the design. We also reinforced the middle even more because we were most concerned about it breaking there due to the force of the plate. We added K-shaped joints on each side of the hole where the plate would be, and then connected them, reinforcing the area around the middle as much as possible. Finally, we slid long rectangular pieces between the 2 layers of diagonal pieces. We did this in an attempt to spread out the force exerted on the middle of the bridge, evenly distributing the force and allowing our bridge to withstand the greatest possible weight.
A couple other things is we added little bars in here. They still allow 4 inches of clearance, but it makes it harder for these things to pop out of place. We also reinforced our bottom a lot more, especially because we realized that's where it's going to break the most. So we have these beams going across here, and especially this middle area where it's going to break.
How much did it record again?
111.7%.
What do you think we could have done differently?
Perfect.
I think a couple of these joints kind of came off here. We could have maybe made these stronger.
And
then what
it
broke
didn't
first
break in the middle. It broke.
is this thing got retracted from here.
Yes.
That was the first thing to break.
Mhm.
So maybe we make that a little stronger next time, and then it goes to 1,000.
Yeah,